Hi everyone, Paul Smith here from Teagasc Grange. Sorry I can't be there to present in person as I'm still traveling to the GGAA, but I just wanted to thank Suzanne Rowe and the rest of the organising committee for today's workshop for giving me the opportunity to present some of our data. So the presentation I'm going to give today is titled Estimating Methane Emissions with the Green Feed System. So a bit of an introduction to myself. So my name is Paul Smith. I'm a research officer in Teagasc Grange in Ireland, and my contact details are down there below. Should anybody want to follow up with any questions about today's presentation. So here's an overview of Ireland and just give you an idea of where we are in Teagasc Grange. We're about 45 minutes outside of Dublin City on a research farm that is about 250 hectares in size and is about 1,100 cattle at any time. The research program, I suppose, carried out at Teagasc Grange, naturally enough, is focused on sustainability and methane emissions reductions as well as nitrogen output, but also focused on everything from animal welfare to grassland management, nutrition, farm systems research, as well as, I suppose, meat eating quality as well. So a bit of an overview of our infrastructure when it comes to measuring methane emissions at Grange. So we have, I suppose, a dedicated in vitro lab in Grange, which we use for screening quite a lot of feed additives. We have the Rusitech system as well as the batch culture system. We have 11 green feed systems that are both indoors and outdoors, which are again used for the feed additives, as well as some breeding research, as well as validating our national inventory. We estimate intake from animals when they're indoors via the Callan Gate system, as well as the Incintec. And then when animals are at grass, are using the N-alkane bolusing technique. And then we also have a dedicated team and lab, molecular lab, which is used for, I suppose, looking at rumen microbiology as well as some of the genetics and other molecular techniques when it comes to looking at methane emissions from cattle. So the green feed system, I suppose, look, most people are probably aware of what the system is, but just to give you a brief overview of it, it's a non-invasive web-based system which is used for estimating gaseous emissions such as methane, carbon dioxide, oxygen, and hydrogen. Real-time data collection using mass fluxes, which are reported as in terms of grams per day. And data collection with the unit is firstly based on voluntary animal usage. So the animals don't use the unit, we don't get any data. And then it's basically, I suppose, an amalgamation of numerous short-term breath measurements throughout the test period is what we aggregate up together to get a value for each animal. How the system works, again, not going to labor the point in too much detail, but the way the system works is basically each animal is fitted with an air tag. The animal approaches the unit, the system recognizes them, drops a bit of bait feed to keep the animal using the unit, an extractor fan up the top of the unit, then extracts all the air surrounding the animal's head, passes it into the unit, comes up the exhaust pipe here, an inlet of this or a sample of that gas is taken via an inlet pipe, goes into the bottom of the unit and passes by sensors which are used to estimate those different gases. That data is then relayed to CLOC via the internet, Wi-Fi or cellular modem, and then CLOC pass the data onto ourselves. So when it comes to the green feed system, there's three primary equations which are used to estimate your methane output or your gas flux. Firstly, it's the calculation of airflow. After that, then I suppose it's calculating gas concentrations. So that's mainly, I suppose, a lot of that's to do with calibrating the data that's going through your sensors. And after that, those two equations then feed into the final equation, which gives us our gas flux, which is basically using some of this data from the two previous equations and also adjusting for the ideal gas laws as well. So the first two equations, as I said, airflow and gas concentrations. When you get your green feed system, you'll be doing quite regular calibrations with those systems. And these calibrations are key to, I suppose, accurately measuring methane emissions from these animals. And different calibration systems are in place. There's manual and auto calibrations, and they very much depend on the different model that you have with the systems. So the two calibrations, as I said, the first calibration is, I suppose, looking at gas calibration. So that's to validate the sensor accuracy. So basically what we do is we put in a known concentration of methane, carbon dioxide, and a balancing gas, pass them into the unit and make sure the sensors are basically picking up those concentrations of gases. And if not, if there's any drift, there's a calibration coefficient calculated, and or maybe perhaps the sensors need to be blanked. And then there's also gas recovery, which is basically we pump through a known amount of CO2 into the unit, see if the machine is able to calibrate or to pick up that known amount of CO2 that we've pumped through the unit. And based on that, then we use that to estimate or to calibrate the airflow going through the unit. So both of these calibrations are used within those two equations, which I previously showed. So when it comes to actually the practical side of using the green feed system, two things that I would well, one thing particularly I'd recommend doing is spending quite a bit of time designing your pens for the green feed system before you use them. Firstly, you need to have a system in place that will allow unrestricted one animal in, one animal access out, access to the unit to, I suppose, stop any cross contamination, if you want, for want of a better word, of animals breeding in and out of the unit, but also just to make sure that animals are undisturbed when they're going into the unit. You'll also need to, I suppose, be very careful with it, as we learned the hard way. Make sure that all wires and gas tubing are well tucked away so that the animals aren't able to I suppose, gnaw on them and disturb your experiment. Also, what I'd recommend is having a nice protective area for yourself to allow you to work at the back of the unit, and where that's basically where most of the hardware is that you'll be using on a regular basis, in terms of changing your air filters, as well as potentially if it's old school, it's looking at doing manual calibrations, but also if the auto calibrations are at the back of the unit. So it's when it comes to designing the unit, as we had here, allow a nice bit of area for yourself to work within the unit. Also, again, this is just the backside that we had of the unit here to allow us to perform our calibrations. The unit will need to be obviously protected from the animals, which kind of goes without saying, but also the unit needs to be, I suppose, strapped down to the ground, to, I suppose, make sure that when the animals are using it, they aren't shaking the unit and basically disrupting the sensors. The sensors can be quite sensitive to strong jerks from the animals and strong shaking. So what we do is we bolt the systems down into the concrete, both on the floor as well as on the back of the unit as well, to again stop the unit from moving around. So again, when it comes to using the green feed system, training the animals to use the system, it might sound silly, but is absolutely crucial. As I said, if the animals don't use the unit, you're basically not going to get any data. So you need to make sure your animals are regularly trained to use the unit to allow them to, I suppose, become regular users of the unit. What we tend to do is firstly give them unrestricted access, whereby there's no alleyway gate put up and just the unit being protected itself, and allow the animals all regular usage to the unit. After that, then over a period of time, maybe 2 to 3 weeks, depending again on how quick the animals adapt to using the unit, we eventually put up the inlet gates. We put up the gates to allow then one animal in, one animal out, and put on the headboards again, just to make sure that only one animal is using the unit, and allow the animals again start getting, I suppose, adjusted to the measurement period, which is going to be used throughout the experiment. And again, just to emphasize the real key, I suppose, with the training side of it. So when we first got our pasture green feed systems, this was back in July 2022. There was a slight delay in getting the unit shipped, so we weren't able to train the animals before they went out to grass. So these animals were allowed access to, or the green feed stayed with the animals from July to October with our suckler cows, as part of a herd that we call our maternal herd. And over this period, only about half the animals became regular users of the green feed system. And we primarily put that down to the fact that the animals had, I suppose, never seen a green feed system before and weren't, I suppose, trained how to use the unit. But what we did then over the winter period was indoors, we gave the animals about a week's worth of training to use the unit. And we found that after that week, about 95% of the animals became regular users of the green feed. And I suppose as part of that, it's, I suppose, as I said earlier, allowing all the animals to use the unit in an unrestricted manner. But for some animals that, I suppose, become a little bit more hesitant or maybe are getting bullied or something like that, what we tend to do sometimes is allow them, I suppose, protected access to the unit. What I mean by that is we put them behind a gate, an alleyway, as I said, with a backing gate. We allow this gate to swing by here and allow those animals their own time to, I suppose, to adjust to the unit. While the rest of the animals are away, to again just get them used to adapting to the unit. As I said, they could be getting bullied, or they could be just nervous animals that aren't used to using the unit. Now, as I said, before every experiment, we do give the animals an adaptation and training period, and we're probably getting, depending if it's indoors or outdoors, probably somewhere in the region of 80 to 90 odd percent of the animals becoming regular users of the green feed. We have a paper that we're currently working on, which is looking at the minimum visitation number for those, for what we class as a regular user of the green feed system. And what we'd be looking at probably is animals which are, when they're outdoors, it's probably going to fall somewhere in the region of between 50 to 60 measurements that are needed. And then if an animal is, if an animal's in outdoors, between 50 to 60 measurements are required. And when an animal is indoors, it's about 30 to 40 measurements which are required. And those are measurements which are 3 minutes in duration. As I said, we're primarily working on that. We're working on the data at the moment with the aim of publishing it in the paper. So I'm just not presenting it there today. So then when it comes to running your experiment again, you can log on to your green feed system online or you can check it on your phone. And key things just to look out for are your airflow. Make sure your airflow is not dropping. And if it is, your filter is likely dirty. So make sure you change your filter. Calibrations, make sure your calibrations A are happening if they're on the auto calibration system. And B, make sure that your coefficients that you're getting are quite consistent over the period. The feed bin, so make sure that's make sure that's regularly topped up with feed. What we have found in the past, if for some reason by accident the feed bin did run low, animals do get discouraged from going to the green feed system and may lose interest in it. Naturally enough, they're not getting fed. So make sure the feed bin is topped up regularly. And then also key thing is just to make sure that the animals are using it during the green feed, during your measurement period as well. And all that can be done either you can see how quickly or sorry, how regularly the animals are using it via the online portal or looking at the app on the phone. So moving on then briefly, I'm going to touch on this. So one of the key things I'm often asked is the green feed system, or how confident are we in that the measurement coming from the green feed system is accurate? Now, unfortunately, we don't have the respiration chambers in Southern Ireland. So what I've done here is looked at values that we've got for actual measurements from animals and then looked at how they related back to what those animals predicted methane output based on a variety of different equations. So the data that I'm using here is coming from about 300 animals that we measured at the IPCC, that's the Irish Cattle Breeding Federation's progeny test center. This is basically a feedlot whereby they progeny test the AI bulls and the national AI bulls in Ireland. As I said, we measured methane emissions in about 300 crossbred beef cattle from that test center, including also feed intake, average daily gain, feed efficiency, etc. And we used that measured data and then also looked at what the animals predicted methane would have been based on a variety of the different Yann equations. So we were looking at predominantly three of the different Yann equations, the Yann 2000 equations, as well as the Yann 2009 equations. And the reason why we went with this, these would have previously been, I suppose, guided our national inventory in Ireland. So it's just the main reason why we've gone with the Yann equations. So I said there's the three different equations. So what we found between the measured and the predicted methane output for these animals that we measured, we had about 300 animals, as I said. They produce an average methane output of about 230 grams. They were eating about 10.5 kilos and about 510 kilos body weight. And when we put the animal's gross energy intake, digestible energy intake, or metabolizable energy intake through the various different Yann equations, we can see there is actually not that much different between the predicted and the measured green feed methane output coming from those animals. So the first one, the Yann equation based on gross energy, pretty much identical in terms of the average methane output versus the predicted methane output. Again, the one on digestible energy intake, again, pretty much identical, off by about 2 grams. And then looking at the MEI versus DEI equation from Yann in 2009, we are seeing that there's about a 12-gram difference, which again, pretty similar, the measured versus the average predicted methane output from those animals based on that large study. So based on this, we would have confidence that when it's calibrated correctly, the green feed system is producing a figure which is coming up accurate based on the energy intake of those animals, and when we measure it back against the predicted equations. One thing, however, we are noticing, oh, sorry, no, the wrong slide. So looking at the factors influencing methane emissions. So again, just to labor the point that the green feed system is kind of working as we had expected. The main factors which traditionally been associated with methane emissions are holding with the green feed system. So this is based on about 207 animals across 6 different studies at Grange. These are basically control animals from our variety of our different feed additive studies. And what I've done is I've ran a stepwise regression on their performance traits, mainly intake, growth rate, that type of thing, and trying to see which ones were the main factors which were influencing methane emissions. And as we can be consistent with the literature, we can see that dry matter intake is still staying strong as a good predictor of the amount of methane that an animal produces, with a just R squared of about 0.5. Coming from a strong, again, correlation coming there for relationship of methane output with dry matter intake. And again, primary reason for that is the more the animal eats, more fermentation, more hydrogen and carbon dioxide, and subsequently more methane emissions. As I just wanted this is just used as an example to again just show that the same factors which have previously been associated with methane output are holding true for the green feed system. However, one thing we are noticing with the green feed system is our YM factors, that's the amount of energy, the animal's gross energy intake that is lost as methane emissions. We are seeing that they tend to be a little bit higher with the green feed system than what, from our data anyway, for beef cattle than what has previously been reported in the IPCC. Now I know these are just estimated ranges for what the IPCC comes from, but we have variety of different factors here for beef cattle. So if the animal is has about over 85% of the diet coming from grain feedlot, they should have YM factor of about 4.7. And then if there's over 75% of the diet coming from forage, 7% and 6.3% as well. Looking at the data from some of our published data, but what I will say is some of our data that's currently undergoing the review process is following a similar trend. Um, we are seeing that across a variety of different diet types, forage to concentrate ratios from 50-50, 60-40 to 25-75, we are seeing that the YM factors are a lot higher than what would have been reported, I suppose, for those type of categories of diets in the IPCC. So that's just something just to leave you on a cliffhanger of something that potentially could be discussed within the workshop and as the rest of the conference goes on. So that's just some of the data that we're finding with the green feed system. Apologies, guys, with dog side the bark there. With the YM factors coming from the green feed system. So with that, to conclude, guys, so regular calibrations to green feed are crucial for an accurate measurement. Animal training is required to get regular visitation to the units from animals. Good agreement between predicted and green feed measured methane output based on the Yann equations, and potential revisitation within Ireland, perhaps for the YM factors for methane output coming from the green feed system. And sorry, I should just mention this also, while we are seeing a higher YM factor coming from the different diet types, they are within ranges which we've previously found with the SF6 technique. So it's not that these are outliers as such within an Irish context. So with that, guys, look, I'd like to thank you very much for your attention here today and hope you've enjoyed the rest of the workshop. Again, my contact details are up there, and I will hopefully meet up with some of you as the rest of the conference goes on. So with that, guys, again, thank you very much for your time, and thank you again to Suzanne for the invitation. And I hope you enjoy the workshop and see you over the conference.